Okay, let's try a Bernoulli problem. I like those. Here we have an airplane with a given mass. It's got two wings, each with a given length and width. The wing is designed so that the air that goes over the top travels 30% faster than the air traveling over the bottom of the wing. What is the minimum speed necessary to allow this plane to fly? And we get to ignore all those second order effects we talked about in class. Okay, like always, the first step whenever you're solving a physics problem is to draw a picture. Let's draw a picture of the aerofoil shape of a normal everyday airplane wing. This wing might be traveling forward along with the plane at a speed v, and it's then experiencing air coming this way, also at speed v on the bottom, but the air on the top has to wrap around and go a little bit further in the same amount of time and therefore faster. And we're given that the velocity on the bottom, of course, is going to be equal to the velocity of the plane, and then the velocity on the top is going to equal 30% more than the velocity on the bottom. Okay, next step, free body diagram, of course. So let's try drawing a free body diagram of this wing. Going down, of course, we have the weight of the airplane, but also, and then going up, we've got the pressure of the air on the bottom part of the wing pushing up on the surface area of the wing, and that gives us the force on the bottom, not to be confused with the buoyant force, of course. But we also have air pressure on the top pushing down. But of course, the air pressure on the top is less because the air is moving faster over the top. And if this thing is indeed in equilibrium, and your plane is not either accelerating upward or crashing down to its fiery doom, the sum of the forces have to add up to 0. Okay, next step is let's write out Bernoulli's equation. I remember we can derive Bernoulli's equation by using conservation of energy, but basically, if we're looking at the bottom, the pressure on the bottom plus rho gh of the bottom add 1/2 rho speed at the bottom of the air has to equal the pressure at the top add rho gh top add 1/2 rho v top squared. Now, the bottom of the airplane wing is pretty much at the same altitude as the top. They're basically about equal. So that means that these terms right here, the rho gh's, go away. Now, this right here is Bernoulli's equation. And then, from our free body diagram, we end up getting that pressure at the bottom times area, don't forget that area, has to equal mg add pressure at the top times area. Okay, now if we look at this, we see that we actually now have 2 equations and 2 unknowns. And we got a couple minutes before my YouTube slot fills up, so let's try to solve this really quickly. Let's call the top equation 1. Let's call the bottom equation 2. Basically, we're going to get that the pressure on the bottom subtract the pressure on the top, this would be the pressure differential, is going to equal 1/2 rho v top squared subtract 1/2 rho v bottom squared. This is from 1. From 2, we get that the again, PBA, actually, I'm going to let you figure out the A. I'm going to pull the A out of the top. Basically, I move this over here and then pull the A out is going to equal mg. Come back, okay. I'm going to divide by A on both sides, so that goes away. And we end up getting that mg over area is going to equal 1/2 rho vt squared subtract vb squared. But remember that we were given that the velocity on the top is equal to 30% faster than the velocity on the bottom. And this turns into 2mga over rho is going to equal 1.3 squared subtract 1 squared vb squared. Or in other words, 2mg a rho, I think 1.3 squared is, probably 1.69. And come back, okay, and therefore this whole chunk becomes 0.69 is equal to the velocity on the bottom times all that squared, and now you can plug and chug numbers in, and that's our answer. Hey, that was kind of fun. Okay, I think that's it. I hope you've enjoyed your Monday class. Please do send me emails if you have any questions. I'll be answering emails Monday night from 9:30 to 10:30. Have a good day.